Hi, welcome back. Let's just start our introduction with talking about chemistry in context. So, with that, let's see what is chemistry. Well, chemistry is the study of the composition, properties, and interactions of matter. But what is matter? This is an important question, right? Because based on this definition, chemistry deals with matter. So, what is matter? Well, this is Earth, the planet that we live in, and it is built of material, built of water, rocks, soil, air, etc. And if we zoom in a little bit, we can see that this is New Hampshire, right? And New Hampshire is also built of material, built of things, right? We have land mass, we have water, we have air above it. So New Hampshire is also built of material. And we can zoom in a little bit, and here is Manchester. And these buildings are material too. We can actually touch them, feel them. And the chemistry has a thing about this. A friend of mine is an innovative civil engineer, and he uses chemistry a lot to modify this matter to work better for him and others, to make concretes that are more durable. And chemistry has a role in that for sure. We can zoom a little bit more, and here is Benji, and Benji is built of matter. And if we dive into Benji, into his body, boom, you would see something like this, which is his cells. But the cells themselves are composed of stuff material, and material themselves composed of even smaller components. So if we zoom in, or we dive in into these cells, we find something like this protein molecule. And at the molecular scale, at this level, chemistry is trying to make connection. Why certain molecules behave in certain or different ways. Why some conduct electricity while some other molecules don't. How we can modify these material, how we can modify these molecules to better use them as engineer, as doctor, as environmental scientists. For example, this one is a big protein, and the individual colors that you can see here are atoms. And this whole thing is a molecule. So if we zoom in more, and we may see individual atoms here, which, well, they do not look like exactly like this, but we can represent atom just like this. And we're going to talk about atoms in the future. What is their structure? What are electrons, protons, and neutrons? But here we want to have general pictures, right? Generally, we can say that smallest particle of an element that has the properties of that element can be defined as atom. All right. So now that we have a general understanding of chemistry, what is matter, and knowing that we are going to discuss chemistry mostly at the molecule level, let's look at the chemistry from another perspective. Chemistry is sometimes referred as the central science. At least that's something that is mentioned in your textbook. I cannot say that if I completely or 100% agree or disagree with that. That's an opinion. That's not a theory. That's not a law that chemistry is the central science. That's just an opinion from the author. And you can accept or not accept that opinion. But one thing that I can tell you, chemistry is a very useful tool in your toolbox. No matter what your future job is going to be, having a general understanding of chemistry would be a very useful tool in your toolbox. And in this current job market, in today's world, you would like to have as many useful tools as you can in your toolbox. So I don't know if chemistry is the center of science or not, but I can tell you that this is an opportunity for you to learn about a science that can potentially be very helpful for you, very useful for you in the future. And because it is a science, because chemistry is a science, it is following the scientific method. But what is scientific method? Well, the scientific method basically is a problem-solving approach. So if scientists want to solve a problem, how they solve it is by following a few steps which are defined as scientific method. And basically we can say that scientific method has 5 basic steps. Step 1 is observation. You make an observation which can be quantitative or qualitative, but you make an observation, and after deciding to learn more about an observation or a set of observation, scientists generally begin an investigation by forming a hypothesis. Hypothesis is a fancy way to say a tentative explanation for the observation. So you make an observation, for example, you cannot start the engine of your car. That's an observation. So you need to have a tentative explanation why you cannot start the engine. And you say, hey, maybe it's because the car ran out of gas. That tentative explanation is your hypothesis. Now, the third step is to test that hypothesis. How we test that hypothesis? Through experiments. If we cannot test something, that cannot be considered as a hypothesis. Now, when we test that hypothesis through the experiments, there might be 2 outcomes. The first outcome is that the results are not consistent with hypothesis. You add gas to your car and still the engine is not working. So that rejects your hypothesis. So you need to modify your hypothesis. Or your experiment is in accordance with your hypothesis. You add gas to your car and the engine starts working. So you move on to the next step, which is our 5th step, which is development of a law or a theory. So we're going to talk about differences between law and theory, but in the case of our car example, you can come up with a theory that says, hey, if the car engine is not working, it is probably because the car ran out of gas. So that's a theory. And the theory themselves can be modified and developed and changed. Or you can have a whole different set of observation and come up with a law. Just remember, laws and theories are completely different things, and one cannot develop to become another. Like theories cannot evolve and become laws, and laws cannot evolve or change and become theories. They are completely different, and we're going to talk about that in a few steps. So again, scientific method is a problem-solving approach that many scientists, including chemists, use to address questions that we face in science. And it has 5 basic steps, starting from observation, formulate a hypothesis, design and perform experiment, accept or modify the hypothesis, development into a law and or theory. All right, let's review these 5 steps with an example. Let's suppose that you got 2 slices of bread, put them into a toaster, and press the button. However, your bread does not toast. So that's our observation. The toaster is not working. Now, as a scientist, you probably want to come up with a tentative explanation why the toaster is not working. And that tentative explanation is your hypothesis. In this case, we can say that our hypothesis is that the toaster did not work because the electrical outlet is broken. That's one explanation, right? That's hypothesis, but we need to test the hypothesis, which is our 3rd step, to run an experiment to test the hypothesis. So to test the hypothesis, we need to make an observation or perform an experiment associated with that hypothesis. In this case, we would plug the toaster into a different outlet and see if the toaster is working or not. So that's the 3rd step, to test the hypothesis. Now, this experiment can have 2 different outcomes. The first outcome is that our hypothesis will be proved. And the second outcome is that our hypothesis will be rejected. If our hypothesis is rejected, it means that the toaster does not toast. We need to modify our hypothesis. Like we can say maybe there is a broken wire in the toaster, and that becomes our new hypothesis. Then we need to test that hypothesis. But if our hypothesis was approved, if we plug in the toaster into a different outlet and it starts working, then we can move to the next step, which is developing a theory or a law. And in this case, we have developed a theory, which is if the toaster won't toast, it may be due to a broken outlet. Now, this theory could have been modified to a better theory, which is if the toaster doesn't work, it may be due to a broken outlet or a broken wire in the toaster. And that's because different people made this observation, made this experiment, and get two different outcomes, and they put their results together and come up with this modified theory, which says, hey, if your toaster is not working, it's either a broken outlet or a broken wire in your toaster. Now, you might ask why we call this theory, not a law. But before that, let's review what we got so far. So far, we know that to address a question in science, we use scientific method, and scientific method has 5 steps that we just described here. And we use a simple example of toaster to explain those 5 steps. And in our example, we came up with a theory. Now we want to know why we call this a theory, not a law. So we go to the next slide in which we're going to discuss the differences between a theory or law. Now, if we want to understand the differences between a theory and a law, we need to pay close attention to their definition. The law of science describe or predict some facets of the natural world. So laws generally have a predictive power, but they do not address the question of why. They predict, but they cannot tell you why something is happening. They can predict that if I drop a pen, it will hit the floor, but it cannot describe it why. A theory, on the other hand, provides a testable explanation of a particular aspect of nature. In other words, a theory can address the question of why, but cannot predict some facet of the natural world. Let's see a few examples. How about that? We have a sentence here. Just you let me know if you think this is a theory or a law. Universe began almost 14 billion years ago with a massive expansion event. What do you think? Do you think this is a law or this is an event? Oh, this is a law or this is a theory? Think about it. You're right. This is a theory. Why this is a theory? Because it addressed the question of why. Universe began almost 14 billion years ago. Why? Because a massive expansion event happened. Now let's look at this second question. So yes, this is a theory. This is the Big Bang theory. Now let's go to the second sentence. Any two objects, no matter their mass, exert gravitational force toward one another, and we can predict that gravitational forces using this formula. So if we have a formula, that formula can predict something for us, right? So this description here has a predictive power, and because it has a predictive power, it is a law. And yes, that's the universal law of gravitation. You see, this one addresses a question of why, so it's a theory. This one predicted something, so this is a law. So which one of the following statements is the most similar to a theory? Let's go one by one. A, falling barometric pressure precedes the onset of bad weather. Is this a why or this is a prediction? Basically, this one is saying that if the pressure drops, we are going to have a bad weather. So it can predict something. And because it has a predictive power, this is a law. This is not a theory. So we move on to the next one. All life on Earth have evolved from a common primitive organism through the process of natural selection. It describes something. It does not predict something. It's about the past. So because it's describing something, it's not predicting some facets of the natural world. It is a theory and it's not a law. Now let's go and check C and D. My truck gas mileage has dropped significantly, probably because it's due for a tune-up. This one also provides a description. It's not predicting something. Gas mileage dropped. Why? Because it's due for a tune-up. So why this one is not a theory? What do you think? This is a theory? This is a law? What is this? Well, number C is a hypothesis. It's not a law. It's not a hypothesis. Why? Because it's not being tested. We think that my truck gas mileage has dropped because it's due for a tune-up. In order to this hypothesis become a theory, we need to go and make an experiment. For example, we need to tune up the car and see if the gas mileage will drop or not. If the gas mileage drops, then yes, that hypothesis is approved and we can come up potentially with a theory. But for now, this is a hypothesis. Number D, we have previously discussed this. It predicts something, so it's a law. With that, let's watch a short video together about differences between theory and law from TED Ed to even better understand this topic.
Chat with a friend about an established scientific theory, and she might reply, well, that's just a theory. But a conversation about an established scientific law rarely ends with, well, that's just a law. Why is that? What is the difference between a theory and a law? And is one better? Scientific laws and theories have different jobs to do. A scientific law predicts the results of certain initial conditions. It might predict your unborn child's possible hair colors, or how far a baseball travels when launched at a certain angle. In contrast, a theory tries to provide the most logical explanation about why things happen as they do. A theory might invoke dominant and recessive genes to explain how brown-haired parents ended up with a red-headed child, or use gravity to shed light on the parabolic trajectory of a baseball. In simplest terms, a law predicts what happens, while a theory proposes why. A theory will never grow up into a law, though the development of one often triggers progress on the other.